All right, we're doing a variety of different things today, so I want to get through all of them with you so that you have time to work on your homework before you leave. Is that all right? Okay. So first of all, we're going to talk about growth versus decay. Okay. You should be able to look at an equation and tell me if it's growth or decay. And if you can't tell by just looking, because sometimes they're not set up that way, there's some steps that you can go through to then be able to look and tell if it's growth or decay. And even tell me what percentage of growth or decay there is. Okay? So let's start off by just being able to look, first of all. Okay? So y equals 7 to the x power. Is that growth or decay? How do you know? How do you know it's growth? Because the base is greater than 1. Okay? What about this one? Y equals 1/2 to the x. Decay because the base is between 0 and 1, right? What about this one? Why is it decay? Yeah, but don't we multiply it by 2 first? No, we don't ever do that, do we? That was harsh, I'm sorry. We don't ever multiply these, can we? Okay, but it is decay because the base of the exponent is between 0 and 1. And what about this one? Because? Okay, so growth because it's greater than 1, all right? Any questions about that so far? It's pretty straightforward, right? Nothing. Yeah, if the base is 1, it's just a line. We talked about that the other day in our notes. Okay? So what about if it looks like this? Is that growth or decay? Yeah, that's the appropriate response. All of these were straightforward because what are the exponents? X. Okay? This exponent is not x. So I have to do a little bit of manipulation to make it just be an x, because then I'll be able to look at the base and tell if it's growth or decay. Okay? So here's what I'm going to do first. First of all, I'm going to show you every step, and then I'll make sure you know which steps that are okay to skip if you're comfortable with them. Is that okay? Okay. So we're going to start here. 4 raised to the 1/6 times t. Can I separate that like that? Why? T over 6 is equal to 1/6 times t. And am I allowed to separate things like that? Yeah, absolutely. Okay. Now, am I allowed to do this? I am, right? This is just basically a power to a power, isn't it? Okay, so I can bring that inside like that. Well, is 4 to the 1/6 something I know off the top of my head? No, but I can use the calculator to figure it out. For today's lesson, let's round to the 100th. Is that all right with everyone? If we round to the 100th. 1.26. Is that what everybody got? Okay. So now you should be able to tell me if it's growth or decay. Why do you think it's growth? It's greater than 1. Okay? It's growth. But like I said just a minute ago, not only are you going to be able to tell me if it's growth, you're going to be able to tell me what percent of growth it is. Okay? And the reason we can do that is because we can go one more step to this. You think I'm allowed to separate it like that? And you remember a couple days ago we talked about a formula that was a times 1 plus or minus r to the x power or t power. And this was our rate. Now, do you see why I want to have it like this? Because what's our rate? So what if I ask those specifically for the percentage rate? You don't want to tell me 0.26 this time, do you? I want you to say 26% growth. Does that make sense? Can we do another one? Okay. So what if this time we're going to do y equals a times 0.25 raised to the t over 9? Why am I not putting a value for a in? Yeah, it doesn't matter. I want you to know that there could be an a value there, but it doesn't matter when determining growth or decay. Okay? All right, so what should I do first? So here, I told you a second ago I was going to write every single step. On this one, is it okay if I write the steps that are okay to skip? That's not what I meant. Is it okay to skip the steps that it's okay to skip? Not write the steps it's okay to skip. Is that okay? You understood? Okay. So what can I go straight to here? You see what step I skipped? Up here, first I separated them and then pulled the number inside. Here I just skipped that step. Okay? So somebody please tell me what 0.25 raised to the 1/9 power is. 0.86. Okay. To the t power, right? Is this growth or decay? Decay. So remember, it has to be, I have to change this into an equation that's 1 plus or minus something to be able to tell what the percentage of decay is, right? So 1 minus what equals 0.86? How did you do that? So you just started with 1 and literally subtracted the number that was there, right, to get what it would be? So 1 minus 0.14. So now tell me, please, the percent of decay. 14% of decay. How are you feeling about this? Okay so far? Okay. Is that enough examples for growth or decay when it's not just x as an exponent? I did one growth and one decay. Is that all right? Or do you need more? Okay, so what if this ended up being like 4? Well, what would that be? 1 plus what? 3. So what percent of growth would that be? 300. Okay. That was a good question. If this happened to be a whole number. Okay. Any more questions about that? All right. So this first example that I showed, or these first examples that I showed you is for the first set of problems on your homework. And these two examples right here that I showed you are for your second your second set of problems on your homework. You ready for the third set? Okay, I'm not going to give you any examples of those. They're word problems. Okay? It's taking all the stuff we just talked about and putting it in words and see if you can read it, see if you can figure it out. All right? I have confidence that you can work through that. Can you use my confidence if you don't have any? Yeah? Okay. I gladly share it with you. And then the last set of problems on your homework talks about recursive functions. Okay? Talks about using a recursive model. Now, I need to make sure you understand we are not cursing again. Okay? We were never cursing the first time, so we can't curse again for these examples. Okay? Sorry, that was just a little math joke. You're going to be okay. So in a recursive model, you need to know f of 0 and you need to know f of n. Okay? Think back to the worksheet that we did about with the tables on it. Well, what's true every single time at x equals 0? It equals what? Well, if x is 0, what does y equal? Do you remember that? Do you want me to show you the worksheet so you can remember that? I will gladly do that. I just have to get it out of the notebook real quick. This worksheet. You remember that? Every time x was 0, y was a. Every time x was 0, y was a. X is 0, y is a. You remember that? So when f of x, or f of 0, when you have f of 0 for any function, that should equal a. Okay? So what you need to know is the value of f of n. And I'll just go ahead and tell you. It's r times f of n minus 1. Okay? Now, here's something else from that same worksheet. What do you think the R is here? The rate, what else could it stand for? Ratio, right? Stands for ratio. So, was there something that was true on this page that we knew about the ratio? It was always B, right? So, do you think R and B are the same thing? Guys, sometimes math is weird, right? How many different definitions of 0 are there? A ton, right? Sometimes we use different letters to stand for the same thing. Sometimes we use the same letter to stand for different things, right? This is one of those times when we're using R and B, like if we're doing this, the general form, y equals a times b to the x, to mean the same thing, all right? So this is going to be really, really hard, so I want you to pay really close attention. Are you getting the sarcasm? Okay, just making sure. So if I tell you the exponential model is f of x equals 5 times 9 to the x, this is the exponential model. I want the recursive model, which means I have to list f of 0 and f of n. In this problem, in this exponential model, what is f of 0 going to equal? 5. In this model, this exponential model, what is f of n going to equal? What's the r? 9 times, done. This is the exponential model. This is the recursive model. R-E-C-U-R-S-I-V. See what I mean? That is super hard. Okay, then I'm going to make it even more difficult. F of x equals 1/3 times 2 to the x power. Look, I even wrote it different. It even looks different. What's f of 0? 1/3. What's f of n? 2 times. Perfect. Done. Do I need to do any more examples of that for you? How could I make this harder? What's the only way I can make it harder? I can make them really ugly fractions, like 1/57, and make this like 326.4. That's the only way I can make that harder. Going from exponential to recursive, it sounds like it's a difficult thing to do. It's not. You got to know the first term, you got to know the common ratio. No, I don't think it's hard. I was just teasing. Yeah. Okay. So how comfortable are you feeling with identifying growth and decay. If your exponent is just straight up x, super easy. How comfortable are you feeling identifying growth or decay and the percent of growth or decay when your exponent is something else besides x? Good. Okay. How comfortable are you feeling writing the recursive model? Really good? Okay, awesome.